Okay, so we started with global and local features, and then we moved to bag of words, and then we built a vocabulary tree. And like in previous videos of this series, now we will be talking about PTAM. PTAM is parallel tracking and mapping, and the paper under discussion was published in 2007. uh, the whole aim of PTAM is obviously to track the robot that is moving along with building the map as well. Therefore, it is called tracking and mapping. And why parallel? Because both the functions, the tracking and mapping, are going on side by side into different threads onto different cores of a dual core computer. Both tracking and mapping are independently going on together, obviously, because they are somehow interlinked, but they are being processed separately in different cores of the computer. This is like the whole idea of PTAM, and this is what makes it so efficient. So we will be talking about this. So let's move on. Okay, so PTAM PTAM map of estimation camera pose is unknown presents a method of estimating camera pose in an unknown location. A split tracking and mapping thread on dual core computer, as I discussed in the start of the video. The method tracks calibrated hand or the robot, obviously, if it is present on the robot in previously unknown scene without any known object or initialization target while building the map. It is like if this camera is, let's say, a robot, and it moved to any unknown location, let's say this. By just doing this, it will automatically find the new pose, as well as it will create the map, and it is creating it like without knowing what the new location is. It was the new location was not known to the robot, and still it managed to track itself and to build the map. Okay, now without wasting the time, let's move forward and see how this like whole phenomena works. So again, same thing, tracking and mapping are going on parallel. Mapping is based on keyframes. Obviously, map is made through keyframes by observation of the environment, and the same map is refined via bundle adjustment. Okay, bundle adjustment is the technique due to which you just minimize the reprojection error. Basically, you refine your map, and then map is densely initialized from stereo pair. Obviously, we will see how. And new points are initialized with the epipolar search. This will we will also see, and at the last, large number of points are mapped. So now let's start how it builds the map and it keep tracks of itself. So map consists of points as well as keyframes. What are keyframes? Obviously, observations from the environment. Each keyframe is downsampled into 4 level. You took a picture, obviously it took a picture and it downsampled it into 4 levels. The uppermost level is 640 into 480, and the lowermost level is 80 into 60. And between these two frames, obviously there will be two more downsampled level. This is done to extract features at different level on different scales. Now the extracted features are called points, and every point will have the source will know, obviously the source keyframe, like every feature will know it is coming from which keyframe, and it will know, okay, it is coming from which level of this keyframe, and then it will also know the exact pixel location within that particular pyramid level. So each point has these three informations as well. So mapping, you have keyframes as well as you have points, and points are obviously coming from keyframes. Okay, so let's begin. Your robot started moving, and it took two pictures. First one is this, and second one is this, and it downsampled it into four levels. I have made it all four together. Okay, and similarly here. Now, what it will do is it will simply extract features from here and here, and it will through correspondences, okay, it will like extract features from here and here, and then it will measure the similar features, and using the correspondences between similar features it will find f matrix, which is a fundamental matrix. This is like prereq, you should know what fundamental matrix is. And obviously through triangularization it will also initialize map as well. Obviously it has found the f. Now with the help of triangularization it can find the exact location, not exact but like it can predict the location of the features in 3D world as well, 3D world as well. So it will do this. This is called map initialization. So this is where this thing come. Okay, it use 5-point algorithm for finding f matrix. Okay, now let's say another frame appeared. Now when will another frame appear? Obviously when robot move a bit further. Now when it moved a bit further, there was another motion model that was keeping a track of the movement of the robot. Okay, that was not like accurate, but you have some sort of motion model that was keeping a track of how much faster or with how much velocity is your robot moving, and until it took another picture, how much distance did it cover. This is found with the help of this motion model, and there are many motion models to find this distance, the distance to which your robot has moved until it clicks the next picture. So you found this r between this frame and this frame with the help of motion model. And why it is necessary? You found, let's say, these four features in these two frames. You found these four features. Sorry, in this frame there were these four features, and with the help of this r you can now estimate where will you find the same feature in next frame. If your robot was moving to the right, then obviously in the next keyframe the same features would have moved to the left, a bit left. And how much left? Obviously the amount of distance it has covered in forward direction. So seeing here it is f1, and the new f1 dash will be a bit left on the frame. See, it is detected here, and then as the robot has moved forward, so the same thing can now be found, the same feature can now be found here. Okay, so therefore motion model is necessary. Okay, so obviously the prior belief, this is your prior distance that can be found, or prior pose that can be found with motion estimate. Obviously now you need to refine this estimate with the help of search. So now it's obvious you don't know the exact location of this feature, but you at least know that it could be around this region somewhere around this region. Why you don't know the exact location? Because this method was not perfect. Now what you will do is to like maximize your or to like minimize your error. okay, or to get a more strong belief whether this feature is present here or not, you will search this patch in the area around this predicted f1 feature, okay, and you will search this. If you have not found the distance moved through this motion model, you could have then you have to search this f in this whole image to get the idea of where the new location of this feature will be. But now you need to search only this region. Why? Because you have now gotten the idea that the new feature will be here somewhere. So you will search it here, and you will refine your belief. If let's say, obviously, in this, where's the pen, in this region you will find fast features, as fast is a corner. So let's say in this region you will find another fast, another fast corner, and you will take ssd between this and this, and with the feature that will be given you the least score will be the exact match, and then you will refine your belief. Okay, this is not the new location, this is the new location, and this is what you will do with every other feature as well. Okay, now, so this was what I was talking about. Okay, this was your feature, this was your predicted location. You search this area, and in this area you search different fast corners in this picture, and then you estimated the new location of f1. Okay, now you have the new estimation of this feature in camera frame. Okay, okay, so now next, as you were tracking your 3D map as well when you were building the map, along with that you were obviously keeping track of your pose as well. So for example, your previous location was, let's say, 8. For example, it was 8. Sorry, where is my pen? Okay, so let's say previously it was 8. This is very like I'm doing it only to make sure that you are understanding the concept. So let's say this was your previous estimate, and now you moved a bit. Now what actually happened is this point in 3D environment will get some translation as well as some rotation. Okay, this point will have some translation and then rotation. So this thing can be represented in this equation. So you have the previous pose that I'm saying, let's say it. Okay, it cannot be a single number, obviously it will be like coordinate, and the new point in this keyframe until this came will be equal to its product with translation and rotation. You have done it in camera when you were solving camera models. Okay, you have the previous estimate, you will multiply it with transformation matrix to find your new pose. So this E is your previous pose, you multiply it with transformation, and here transformation matrix is simply represented by this vector mu, which contains 6 numbers, and where first 3 numbers are xyz and remaining 3 are representing the rotation. You will multiply it with this and you will find the new 3D location. This is the new 3D location. Okay, so now to project this into the camera, this is the 3D location. To project this into your camera, you will multiply this with projection matrix. You will multiply this with projection matrix to find its projection in the camera model. But you already know like location in the camera when you were doing this thing. So what you will do is, you already know a location of a certain feature inside the camera model. You will subtract the camera pose that you got from here, this camera pose, this camera pose, and you will try to minimize this error. This is called reprojection error, and this is how you will update your pose as well as your exact location of feature as well. Obviously you know this one. Now you calculate this one, you will try to minimize the distance between two. This thing is called uh, minimizing the reprojection error. Okay, and it comes under local bundle adjustment and